In this question this is an old Coursera data analysis question, and it's interesting as it deals with the analysis of variance model, ANOVA model in other words. And what this dataset will use is the warp breaks dataset, which is a dataset that is inbuilt in R. Let's go to R here, and let's just have a look at it. Head of warp breaks. That's all it is there. Just a very simple data set. Numeric value for breaks and then some categorical variables for wool and tension. And let's get a quick look at the dimensions of it. Warp breaks, dimensions of warp breaks, 54 observations, 3 variables, an outcome variable and 2 predictor variables, or covariates as they're also called. The question: fit an ANOVA model where the outcome is the number of breaks, which is the first variable, breaks. Fit an ANOVA model including the wool and the tension variables as covariates. So there, the breaks, the number of breaks is our response variable, and wool and tension is going to be our predictor variable. What are the degrees of freedom for the tension variable, and what is the F statistic for tension after accounting for variation due to the wool? So what we're going to do here is fit an ANOVA model, and the relevant command for that is AOV. So the help file for that, which is nice, probably a good place to go looking for it, is AOV. Now there's also a different command in there. We have it there. I popped that up there. So fit analysis of variance model. You can sort of find that yourself pretty easily. I'll close that down. So the way we're going to do this is we're not going to fit any interaction effects or anything like that. It's a very simple model. What we're going to do is call it AOV model, and it is the response variable, the tilde symbol, the little squiggle, and the 2 predictor variables, wool and tension. So just a little plus sign between them, and then just the name of the data set. Okay, so let's go back to R. AOV model is just the name of the model we're going to fit. AOV breaks explained by wool and tension, and data equals warp breaks. We're using the warp breaks data set now. There we go. Well, anytime I do that, sometimes I make a little error and make myself look silly, but got it right first time this time. So summary. Let's first off look at AOV model just to see what happens. Okay, that looks good there. But what we could do here, that actually is a sort of specification of the model. I'll widen the page here a bit. But what we could do also is actually use the summary command to get more information again. So summary AOV.model. There we have a very full specification of the analysis of variance table, essentially what the end result. And what we're asked for is degrees of freedom. So that we have them there. 1, 2, 50. Now, if you recall that there were 54 observations altogether, and if you add up all these values here, 1 plus 2 plus 50, you get 50. The number of observations minus 1. So that the degrees of freedom should add up to 53. Okay. That's actually not what we're asked for here, though. Actually, what is degrees of freedom for the tension variable? There we have it, 2. And what is the F statistic for tension after accounting for variation in the wool? So for tension, it is 7.537. Okay. Also, the p-values are there, so you would actually look at the p-values. What this would sort of say is that tension is a pretty important variable once a wool has been accounted for. But we're more interested in how to perform the test rather than with this specific. With this video, we're more interested in how to perform the test rather than actually analyze it, which is more bookwork. All right, that ends this presentation.